children, we are meeting back again with another topic of functions. In the earlier video we discussed about the domain of a function. We considered function as a process which has a set of inputs and a set of output. This set of input was called the domain of the function, and this set of output is called the range of the function. You give values for x, and then in return function gives us values for y. So this set of values of y is called range of the function. Let's see some examples. Example number 1. Y equals x plus 3. This is a very simple function where domain is x belongs to R. X can take all the real values. So easiest way to find the range is to sketch the graph of this function. Let's sketch this and see. This is a straight line. This is the linear function. To sketch a straight line you need to have 2 points on the line. So the easiest 2 points that we can get are we apply x equals 0 and then find the corresponding y value, and then make y equals 0 and then find the corresponding x value. So when x is equal to 0, y is equal to 3. When y is equal to 0, x is equal to minus 3. So we'll plot these 2 points in a graph. Now this is the straight line. Y equals x plus 3. Straight line is this. This is a very simple graph. Now you can see when you go on decreasing x, y also will go on decreasing. In other words, when x goes to minus infinity, y also goes to minus infinity. And when x is being increased, y also will be increased accordingly. So y also can take all the real values according to this function. So the range or the output of this function is also set of real values, right? So the range is the set of real values. Take another example, that is y equals half x plus 2. X belongs to R and x is greater than or equal to 0. Here all the values, real values are not taken for the function, are not input for the function. Only the positive values, only the positive real numbers and 0 are the input for the function. So what is the output of the function, right? We will plot this also and see. When x equals 0, y is equal to 2. When x equals 2, y is equal to 3. In this case I can't take y equals 0. The reason is you can't, when y equals 0, x will be a minus value, minus 4. But in this domain minus is not there. So therefore it is an invalid for the domain. Therefore we can't make y equals 0 here. According to this domain y will never be 0, in other words. So what we would do is we will give a value in this domain. Just take the simplest thing is x equals 2. It's a better simplification also. Y is equal to 3. Now we've got 2 points, 0, 2 and 2, 3. Then we can sketch this straight line. Right. So this is the straight line. All the values of y are more than or equal to 2, greater than or equal to 2. So our domain of this function when x is greater than or equal to 0 is the domain. Our range of this function is y is greater than or equal to 2. So our range is y is equal greater than or equal to 2. Let's go to another example and see. Y equals 4 minus 3x, x belongs to R, and x is less than or less than 2. Here the equality is also not there. X is less than 2, right? We will try to plot this also, right? We will make a sketch of this also. So when x is equal to 2, y will give the value minus 2, right? But actually it is not we can't, it is not legal to apply x equals 2 here, because x is equal to 2 is not in the domain, but as a reference we will take this point. I will show you, and then we will plot this, right? So this is the plot. I have marked this with a circle, that is to indicate this particular minus 2 is not there in the y, because x equals plus 2 is not there in the domain. Y equals minus 2 is not there in the range. So all the y values are more than minus 2. So our range is y is greater than minus 2. Equality is not there because the equality is not here. Understood? So this the domain, so the range of our function is y is greater than minus 2. So now you can very clearly see the range totally depends on the domain input set. We'll take another example, right? That is y equals 3x plus 2. X belongs to R, but x is in between 1 and 5. Other values of x are real values are not taken for this, right? Only these values which are in between 5 and 1, and these two values are also not taken, right? So we will see our output set. We will do this illegal thing and take our reference point to sketch the graph, right? Okay, I have marked these 2 points very clearly with circles to indicate these points are not taken to the graph. So our graph is this line without not inclusive of this, not inclusive of these 2 points. So our range will be y is in between 17 and 5, right? Equality is not there. Clearly note the fact that equality is not there. An examiner might give the same equation with equality only for 1. Then in that case our range also will be different. Equality will be here. So or else he can include the equality here, then the equality will be here also. So you got to very carefully note what our domain is, because the range totally depends on the domain, right? We'll move on and see some more. Now this is another. Now see, all these are straight lines, right? And the equation has similar shapes, but our range totally different from each other because the domains were also different from each other. So when you define a function, see how important to clearly define what the domain is. Okay, So now you take this example. We will take x equals 0, y is equal to 3. Again doing that illegal thing here. X equals 1, y is equal to 5, right? We will take 2. This is x and y. This is 5. This is 3, right? And then, so this is the straight line. In this particular point, 3 is not in the range. Okay, so our range will be y is greater than 3. Y is greater than 3 is our range. Is it clear now? Right? We will take another example. Still we are in the straight line. Right? Y equals 5x plus 2. X belongs to R, but there is a restriction. That restriction is x is in between 0 and 3. X is in between 0 and 3. Note here 0 and 3 are included in the domain. Let's sketch this also and see. When x equals 0, y is equal to 2. When x equals 3, y is equal to 17. Look at this. Right, we marked all those points. This is the line. Here these 2 points are included because these are included. So our range will be from 2 to 17. Our range will be from 2 to 17 inclusive. This is our range. Is it clean and clear for you? Right. Look at this. This is again x is in between -1 and -5 and inclusive of those two values. You can now pause this video and try to plot it all by yourself, right? And then see the domain range, because you know what is to be done by this time clearly. Okay, you pause it and try. Let's see what is your answer. When x is equal to -5, y is equal to -22. When x is equal to -1, y is equal to -2. We will plot those points. Right. Our graph is this. These 2 points are included. So our range will be from where to where? Yes, -2 to -22 inclusive. Yeah, -2 to 22 to -2 inclusive. Right? Did you get the idea clearly? We will take another example. Here, a little bit of a different example. Now this is a quadratic one. Y equals x squared and x belongs to R. Now in the earlier questions, when x belongs to R, y also belongs to R. Y took all the real values. But this is giving you a little bit of a different impression. Look at this. Y equals x squared. We will first try to plot this and see. Right? When you sketch the curve of y equals x squared, it looks like this. It's a parabola. Minimum point of the parabola is 0, 0. Now x can take all the values from -infinity to +infinity, but y will be moving only towards this side, from 0 to positive side only. Y will not take any negative values in this particular case. Therefore, the range of this function is y is greater than or equal to 0. Right? Do you understand? So the range depends on what the domain is, what the input values are, and what is the process or the function is, right? Earlier they were linear ones, and when x was r, y was also r. But here this is not a linear one, this is a quadratic one. When x belongs to r, y was greater than or equal to 0. Did you understand? So now you try to understand the difference. We'll take another example. Y equals x squared plus 3. You know what is the x squared plus 3 curve is, right? So you can pause this video now, back again, try all by yourself, and domain is all real values, right? If you try to sketch this curve, you can get this, right? All the values, actually the previous curve is lifted upward by 3 points. All the values are greater than or equal to 3. So our range will be y is greater than or equal to 3. Y values are greater than or equal to 3. Y is moving this way, right? All the when x goes to this side and this side, y is going this way from this point. So we can say our y values are greater than or equal to 3. Therefore our range is greater than or equal to 3. Our output set is greater than or equal to 3. Output will be this y values. Did you understand? Okay. I think it's well pretty much clear now by this time. We'll try some more examples and see. Next one, y equals x squared, and now in this case there is a domain restriction back again, right? Now this type of domain restrictions you got to clearly understand, because now you see this is, if this restriction is not there, this is not a one-to-one case, right? You can make it a one-to-one function by employing this domain restriction. We will try to plot this and see, right? Sketch this curve in this way. I'm using this plotting and exchanging. Mind you, this is meaning the same thing. Actually, plotting is giving points and smoothly curving. Sketching means just the rough sketch of the thing, right? So y is like this. This half of the curve is not there, right? This half of the left hand side half of the curve is not there because x is not taking those values, and it will not be taking 0 also because x is not taking 0. Therefore my range will be y is greater than or equal to 3. See, the y, all the y values are along this, right? It doesn't go to this side at all. So, and this particular value is not also not taken. So all the y values are more than or equal, more than 0, not equal to 0. So our range will be y is greater than 0. Is it clear? We will see the next example. Y equals minus x squared, x belongs to R. Now you can do it all by yourself and check what your range is, right? This is a very simple sketch, right? It is looking like this. So all the y values are below this. So all the negative values are being taken. 0 is also taken. So y is also less than or equal to 0 here. When it was the positive case, it was greater than or equal to 0. When it is the negative case, y is less than or equal to 0. See how beautiful they are changing. There are differences, right? This function is a very beautiful topic, and which is being involved everywhere also. right? Whatever you try to do in future, there will be functions involved in that, right? Everything is taken as a function. Whole life is a function. Y equals x squared, x belongs to R, and x is greater than or greater than 0. I think I discussed this example earlier, so I will just give this. Could be a mistake, right? I actually wanted to put the equality there and show you. I have forgotten to put the equality. Y equals x squared less than or equal to 0 here. Now you can plot this all by yourself and check what is your sketch of the graph, right? And see. Now in this case 0 is inclusive. That's why I have marked with a solid dot, right? This kind of notation you are familiar with, I think from your small age. So this is the graph. So our y values are still less than or equal to 0, less than or equal to 0. Even for the earlier case was also it was same, range was same, not that, right? But two different domains. Look at this. We will take another. Y equals x squared plus 1. X is greater than 1. See, this is an interesting thing. So we will, this is also the shape is similar to that of y equals x squared and x squared plus 1, but only part of that curve is there because we have restricted the domain. We will see how it is happening. This is the curve with y equals x squared plus 1 and x belongs to R. But this is not the thing we need actually. We need from this point upward, right? This is our function now. So we can take that. So this is our function. Okay. So our range will be y is greater than 2. This is the minimum point. All the other points are taken. Y is greater than 2. Equality is not taken because there is no equality here, right? Y is greater than 2. So the range of this function is y is greater than 2. In the examination actually most of the time it's just write down or state the range of the function. So in that case you don't need any of these workings. What you need to give is a thing like this according to the situation, right? Maybe equality is there, equality is not there, but only this type of thing. It's a 1 mark question. It's very easy by when you take the rest of the question, it's very easily done because this plot is sometimes done in the earlier part of the question and they say state the range of the function or write down the range of the function. Just a matter of writing this only. So it's very easy, right? Let's see this example. This is 2 plus x squared. X belongs to R and x is less than or equal to 2 here. Now the equality is there, right? Let's see. Now how do you do this? Again you plot the curve, right? Or sketch the curve and then see, right? We take 2 points, right? When x is equal to 2 it is 6. When x is equal to 0 it is 2, and if domain was not restricted this part of the curve also will be there. This part of the curve also will be there, but this is not there now because the domain is restricted, it is below 2. So what is our range in this function, right? It is interesting. Sometimes students think of this beyond this point. No, these values are also y values. So our range of this function is y is greater than or equal to 2. Y is greater than or equal to 2, right? Example, x is greater than or equal to 1 here. So I suggest you to pause the video and try it all by yourself and then look at the answer. Play it back again and see the answer, right? When x is equal to 1, y is equal to 3 and y equals to 4, sorry. When x equals 1, y is equal to 4 and it is going like this. This part of the curve will not be there because this x is not there in the domain. X is starting from here, so it is the same thing. Did you understand? Only this portion of the, so this is going up to infinity when x is being increased. So our range will be x is y is greater than or equal to 4. Our range will be y is greater than or equal to 4. I hope you enjoyed this video and you learned the concept of the range from this video. Please like the video and subscribe my channel so that I will be encouraged to give you more and more knowledge on mathematics like this. Thank you. God bless you all.